Hey everyone, welcome to the second session of Functional Programming in Java. I'm Tanya Shah from Women Who Code Delhi, and for today's session, we have Foshwa Duper with us. He's an avid software developer and Java technical advisor for Formatec New Technologies at Belgium. He'll cover streams, comparators, and optionals in this session, and will take up questions towards the end. So please use the live chat window for raising any of your doubts. So, without further ado, let's get started.
Thank you, Tanya. Hi, everybody. Thanks for joining this session about functional Java. So I'll just skip this as Tanya already presented me. If you remember, if you were there in the last session, we talked about functional programming, what it is, and how it is implemented in Java with the functional interfaces. In this session, we are going to leverage the full capabilities of functional programming in Java through some new APIs like streams, optionals, but also through an older API, Comparators, but that have been enhanced since Java 8 to leverage Java 8 functional possibilities. So let's get started with the stream API. So what are streams? Streams are a mechanism of Java 8 to process collections of data. They all start with a data source that can be a Java collection, like a list or a set, but also from the database or also files. So there's just a source. They offer different operations categorized in two categories: intermediate operations and terminal operations. The difference between them is that intermediate operations just give back another stream to us, and terminal operations are consuming the stream. That is, they're completing the operation we are doing at the moment. Streams allows us to hide the iteration mechanism. So it helps us focusing on what we want to achieve rather than how we want to achieve it. So let's just start with the intermediate operations. I won't see all of them in this session because there are a lot and we don't have that much time. But I will see the main ones, those who you will be the most susceptible to use. For starters, let's talk about the filter method. The filter method allows us to tell a stream that we don't want some data based on a predicate. As a reminder, predicates are kind of functions that returns a boolean, so they're basically conditions. So the filter takes a predicate and opts out some elements that are not matching it. We'll just see that in the code. So here it is. So we have a list of people here with names and ages. And let's say we want to filter the people that have under 30 years old. So what we are going to do here is say, okay, here is my list of people, and I want to obtain a stream from it So we just call the method stream that exists on the collection interface. And then we can use all the method offered by the streams, like filter. And so we can just write our predicate here. If you remember, we can do that in the form of a lambda expression, like this. And then we are saying, okay, I want to opt out the people that are above 30. Just if we stop right there, we can't use the data because filter returns us a string, as we can see here. To obtain a list, we have to use this method, collect, and pass it the collectors.toList argument. I will speak a bit more about that later. Just for now, it's a method that allows us to get generally a collection back from a string. Here, a list. So I have my list of people that should be under 30 years old, as we will see in the console in just a moment. As you can see, we have Kevin and Amelia, which is twice here. That was for later purpose. So Robert and Anna have been opted out as they are above 30. Let's get back to the slides. That was filter. What is great about streams is that with the intermediate operations, we can chain multiple operations together. For example, if I now wanted to extract the name of the people that are under 30, I would have to use the next method we'll see, the map method, and pass it a function that from a person returns its name. So for example here, if I want to obtain the name of the people under 30, what I have to do is map my result and say, okay, give me the name of the people. Of course, I have to adapt the type here as I don't have people anymore. And that's just it. We can chain function like this, as many as we want, provided that they are terminal operations. So if I execute the code once more, we can see that we have only the names now and not the people in there. So that's it for the map method, which can take any function. So if I wanted to extract the ages of the people, I could have done that too. Now let's talk about terminal operations, beginning with the collect method, which we already saw a little bit. The collect method takes a collector. A collector is an object in Java that allows to reduce a stream to another object. Generally, it's a collection of some sort, but we could do other things. The people behind Java provided us with a utility class, the Comparators class, which provides a lot of common collectors, like the toList we used just before. But it provides other ones too, like toSet. Imagine here I have my second Amelia back, and I want to just have a set of the people that are under 30. I can use the collectors.toSet here in the collect method, and we'll see that we won't have multiple names for Amelia, which is just one here. There are a lot of other collectors. I will see maybe once or twice here. Let's imagine we want to group people by their ages. So here we will have, for example, a map indexed by age, which will give a list of people matching this age. So basically, the two Amelias would be in the same list. We can do that using collectors. I won't filter anything here. The collectors to do that is called grouping by, sorry. And it takes a function which is the key extractor. So here, basically, it's the age of the person. And as we will see in a moment, that gives us a map indexed by integers, which are the ages of the person, and having as values a list of people, which are the people matching the age. So here, if I say, okay, let's print the people having 30 years old, here is what we obtain, the two Amelias. If I choose to print people having 50, I will have only Robert. And if I choose an age that doesn't exist, I won't have any results, so an empty map. And so null here. That's really handy collector, allowing us to aggregate data based on a key. It's really useful. There is a possibility to nest grouping by collectors. We won't see that here, but just know it's possible to nest the different groupings and have maps, of lists, and so on. There is also a collector to have a map. For example, here, what we could have is a map of the names length of the people by their name. So what I can do is say, okay, I want a map. This collectors is the toMap method of the collectors utility class, which takes two arguments. The first being the key mapper, and the second one being the value mapper. So here I want the name as a key, and I want the name length as the value. And now if I say, okay, let's print the name length of Amelia, of course, I have to make a variable here. So let's print the name of Amelia, name length. We'll have 6. Or not, something went wrong. Of course, there are 2 of them. The default behavior here is to throw an exception, but it's possible to provide a third argument, I think. Yes, that allows us to merge the result, that is, decide what we do if we have two keys. I will do it here. It's not bad practice. So if I have twice the same key, what I want to do is just get one of them here. I won't do something more more difficult. So is it going here? Value mapper, binary operator, h1, h, no, not h, length 1, length 2. Yep. Here, I will just say, let's get length 1. They are the same anyway. And there we go. You have the 6 lengths. We could have choose to do something else, like adding the 2 lengths. That's not very useful here, but why not? You can choose how you merge the two values. So that's it for the two map collector. There are others. The last one I could talk about is the partitioning one. That is quite like the grouping by, but according to a predicate. So for example, here, I put partition the people according to their age. If they are above 30 or under 30 age. Here we go. So I eraser it here. Okay. So basically, we have a map with a Boolean index, true or false. In the true entry, we'll have the people under 30, and in the false entry, the people above 30. So let's just do that right here. Result.get true. True is Kevin and above Amelia's. That's it. And if we go for false, we'll have the others, so Anna and Robert, as you can see here. So that are the main collectors, which are really handy. Let's go back to the slideshow. After collectors, sorry, there's a little bug here. There is the for each method. The for each method does not return anything. It just applies a consumer to each element in the stream. So basically, applies a side effect function, which can be printing to the console, modifying the element, everything that can fit a consumer. Here, for example, if we wanted to print people each one individually, we could do this. Yep. Of course, we can't assign it anymore. That makes perfect sense. And here we are. As you can see, IntelliJ is telling me that I can just calling for each on the collection. That's an improvement of Java 2. There is a for each method on collections. to use directly the functional style on the collection without requiring a stream, because it's not necessary for that. But the for each on the stream is perfectly useful if you have other intermediate operation like we did before, like filtering for people here by age, for example. That's perfectly fine. No, we have only Kevin and the two Amelias. That's it for the for each, which is quite self-speaking. Now, let's talk about the min and max method, which are taking comparators. We'll get a bit ahead of the presentation here, because we'll use the new comparators features. So the min function takes a comparator of the element of the string and gives the minimum element according to that comparator. That is, if in our example I say, okay, I want the youngest people, so I will give a comparator that compare two people on their age and say, okay, this one is less aged than this other one. And the min method will figure who is the youngest person. So here we go. Okay, we have a stream. I want to get the youngest person. And then here, to create my comparator, instead of implementing one, I will just use the comparator.comparing method that creates a comparator for me using a key extractor, kind of like the two map and the grouping collectors. And there is a key extractor. And so I say, okay, get age. And this comparator here will compare the people on their age. So it gives me a result. I'm really teasing you over the follow-up of the presentation, because the minimum method returns an optional. That's because if we apply it on an empty stream, we don't have any results, and instead of returning a null, the Java people decided to return an optional which can represent the absence of the value and force us to deal with it. Of course, here we already know that there is a person matching the minimum, so we can just say, okay, give me the matching person. Here it is. It should be Kevin, as we will see in just a moment. That's it. So there is, of course, the maximum counterpart of this, which is just the max method. And that one should give us Robert as a result, of course, because he is the oldest. So the max method function works exactly like the min function, but it searches for the greatest element. That's all for min and max. Let's go with the reduce method. That is a bit more complicated than the others, as you can see just by looking at the signature. So the reduce method purpose is to get an element from the stream So, for example, it will be handy if we wanted to get the average age of our people. That's what we will do in the example. How does it work? It takes an identity argument that represents the default result. So if the string is empty, that will be our result. It takes an accumulator, which take an element and put it into the result according to the behavior we want to achieve. So the accumulator is a by function. We didn't see the by function on the first part of this course. It's just a function taking two arguments and returning a result. No trick here. And then we have a merger. The merger takes two parts of the result and merges them together. This is only useful for parallelism in case of a parallel stream, but we won't see that today. We just have to implement it, but it generally isn't complicated. So let's just see an example. I was talking about getting the average age of the people here. Let's just do that. So we stream it. And we say, okay, I want to reduce the stream. My identity, as this will be quite a sum, will be 0. That's our average age. That's annoying. Our average age if the stream is empty. Then we'll have a by function to accumulate the results. So it takes the current results and a person as argument. That is the way to start a lambda with multiple parameters. We put parentheses around the parameters and separate them with commas. And so I have here the result, which is a double. And I added to the person age divided by the people's list size. Of course, I have to cast double here. I think. Yep. If I don't want an integer division. And then there is the merger, which takes a result 1 and a result 2 and merges them together. Here it will be a sum. Yes. And so, of course, I don't have the right type here, as we will get a double that is normally an object, but it could have been unboxed. Sorry. Yeah. Here's the result. Of course, I can't. Average age. Let's put it that way. Okay. Here, IntelliJ offers us another way, that is calling double column sum, which is the method reference for the addition of two double. That can be more readable. And so, if we print our result here, which is around 33 years old, if I remember well. Yep, yes, that's what we obtain here. So, how does it work? It is pretty much the same thing as saying, okay, I have a double here representing our average, and I iterate over the people. Sorry about that. Okay. And just put the person age divided by the list size, double test, of course. Okay. This will give us the same result. That's it. So this is basically the same thing, but expressed with streams. That can be really useful if we have a bit of chain operations. Here, of course, the both implementations are quite as readable as each other. Okay, I think that's it for the reduce operation, which is a bit more complicated, but not that much. I didn't talk about the binary operator here, which is like my function, but with only one type. That is, the two operands and the results are of the same type. Sorry. In our example, that was the double type. So here the sum method takes two doubles and returns another double. Okay, that's it for the Streams API. There is still a lot to learn about it, but we should follow up here in this presentation. So, the optional API have been introduced in Java 8 to tackle a real problem in Java and in other languages, the null pointer exception. We all suffered from it. It's still the most encountered exception by Java programmers, so it's really a pain. And the optionals are there to, I won't say solve this problem because they are not the panacea, but they will help us to not rely on null pointers so often as we are doing now. So the purpose of an optional is to represent the possible absence of value. It is a wrapper in which we put a value that may or may not be there. So there are optionals with a value and optionals that are empty and represent thus the absence of a value. It is an explicit way of saying, okay, I give you a value, but maybe there isn't any value, and you have to deal with it. That's quite an improvement comparing to null, because null are invisible. So how do we create an optional object? There are three methods, three static methods on the optional class. The first one is the off method, which takes a value and returns an optional with this value inside. And the value can't be null with the method off. So it's only to wrap a non-null value in an optional that won't be empty. That's not very handy if we have to represent the absence of a value. Imagine we got a value that can be null from a library, and we want to wrap it in an optional. we don't want to test the value for null and then return either an optional with the value, either an empty optional. So the idea here will be to use of_new_label method, which can take a value that can be null or not. And if the value is null, the optional will be empty. If the value is not null, the optional will be filled with the value. And then the last one is the optional.empty method that just creates an empty optional and probably use only one representation of the empty optional. Let's see maybe that in action. Optionals. Yep. Here. So if I wanted to put Robert in an optional value, optional Robert, I could have done this. As I know Robert isn't null, I can use off, but I could have used of_new_label too. The purpose of having the off method, I think, is to not bother with a test if we know the method is not, the value is not null. So the off method knows it can wrap the optional directly. And also, if you are sure that the value is not null, we better use the off method, because if the value happens to be null, then it won't fail silently later because of the empty optional that would have been created with of_new_label. It will fail directly, saying, okay, you give me a null value and I don't accept it. As the null value, the value should not be null. We want to be aware of that as soon as possible. That's the defensive programming. So here we could have done also an empty optional. That's really quick. Optional, dot empty, and that's it. So let's go with the operations on optionals. So there are a few, and some of them are similar to those of the stream API. That's what the Java language people wanted to make some parallelism between the two APIs with functions that are doing pretty much the same thing. So for starters, there is the filter method, which behave a bit like the string filter method. So it returns an optional, which is either filled with the value that it had before, so it's basically the same optional, if the value matches the predicate, and an optional that is empty if the value didn't match the predicate. So if we take Robert here, and we say, okay, I want to filter Robert by his age, and I say, okay, you can do that, of course. Let's put it up. So I say, okay, Robert, are you less than 30 or not? So if I decide to print that, we'll see that we'll have an empty optional printed to the console because Robert is age 50 and so is not less than 30. If we invert the condition like that, we'll see that the optional isn't changed. That's it. So it's useful to check some conditions on a possibly empty value. What I didn't say is that if the value is already empty, the result of filtering that optional will be an empty optional also. Okay. As with the streams, there is a map method which returns an optional, but transforms the value in it if it has one. So the value is transformed according to the function passed as argument. If the optional is empty, the empty optional is then returned because there is no value to update. That is here. If I say okay, I have my optional Robert. Yep. I still can filter it. Up. For now, I will say that. And then I want to get the age of Robert. And I do that. Okay. And I say, okay, let's print the age of Robert only if it is aged more than 30. It is the case. So as you can see here, we got an optional holding 50. If I had said this, Robert is older than 70, we won't have had anything because the optional is empty. So this map method is for me a great way to tackle the null check, the cascading null checks. I don't know if I can make a very quick example here, but let's say, I don't know, yes. Let's say I create a person, somebody, and I'm not giving it him or her an age, a name, sorry. And that's returned by a method. So I have my method get somebody, and I can't know if the person returned is null or not. Of course, here we see it, but if it's an API that says, okay, I may return null, we don't have any clue if the object is null or not. So what we would have done before is something like that. Loop. Imagine we want to print the name, for example. That's it. What we could do now is this body and say, okay, I want to get the name, and then I want to print it. Of course, this example is a bit simple, but the idea is the same for multiple levels of possibly null values. So the idea will be to chain the map calls until we have the value we want to show. And if anything in the chain is empty, the resulting optional will be empty. That's what other languages have implemented through the (dot operator, which is some kind of null safe dot, which say, okay, if something is null in the chain, just return null. Here we can do the same with optionals and the map function. This is a bit more verbose, but that works. Okay. So you see the similarities with the filter and map methods from the Streams API. They are very resembling. Now we are going to see how to get a value from an optional. There is the get method we already seen in the main example of the Streams API. But the get method throws an exception if the optional is empty. So we can't use it only if we are except only if we are sure that the optional contains the value. Using it for all optionals is the same thing as dealing with the pointers exception. It's not better. So there are other methods that allows us to get the default value of an optional. The first one is or else, which takes an argument of the type of the wrapped value in the optional. And this argument is the default value. That means if the optional is filled with a value, it returns its value, else it returns the provided default. There is a lazy version of that method, which is called or else get. And instead of taking a default value, it takes a default value supplier. So the default value won't be created unless the optional is empty. It's pretty useful if the creation of the default value is heavy. Last one is the or else throw method, which throws an exception if the optional is empty. The difference with the get method is that we can choose which exception to launch and give it a message or something like that. So we have control over that exception, which will give us more information than the no such data exception of the get method. This here. So let's maybe do an example. If I do this optional of new label get somebody, I get the name of the person. Yep. And then I say, okay, if the optional is empty, give me John Doe. Yep. And then if I print this on the console, yes, you have John Doe because the person doesn't have a name. So here I wrap the get somebody in an optional. I could have used off as I'm sure the person is not new. Then I say, okay, give me the name of the person. As this returns null, the optional becomes empty. And then I said, okay, or else John Doe. If now I put name here, we'll see that this name will be printed in the console. Okay. So that's the way of giving default value to an option. There is two more methods I want to show you. The isPresent method, three more methods as a matter of fact. There are two that allows us to check the status of an optional, whether it's empty or if it has a value. The isPresent method tells us if it has a value or not, and there is its counterpart, is empty, which is both method exist for with the purpose. And there is that do something if and only if the optional has a value inside. That's quite handy. For example, here we could have said, okay, I want to print the name of the person. Oh. Only and only if that name is present. Yep. That should give us Kevin here. But if I put an here, we won't have nothing printed on the console. So that's a functional-ish way to say, okay, if there is a value, then do something. Instead of doing an if, we just use the if-present method and pass it the behavior to execute. Okay. I see that we have a few minutes left. That should be enough to talk about the comparators. So the comparators already existed before Java 8, but they've been enhanced since with functional features. So the idea is to say, okay, often I want to check on one of their properties. For example, we compare the people on their ages. But it's really painful to write such a comparator because there is a lot of code to write for just saying take the ages and compare them. And so Java offers us new ways to create comparators. With the Comparators utility class that offers us the comparing method. There's a key map which says, okay, compare the two objects on that information. So if I come here in the comparators, so we are back with our list of people. And I say, okay, I want to sort those people using their age. All I have to do is that. And then I can print the people. And we'll see that they will be sorted by age. So we have Kevin and Mike first, then Mia, then Anna, and Robert. That's by increasing age, of course. But now, that's where it becomes really cool. What if we want to compare them by age, and if they have the same age, compare them by name? can use the and then comparing method, which there is a typo. That is not comparators utility class, it's just on the comparator class. So here, if you want to say, okay, compare the age, but what if two people have the same age, like Kevin and Mike, here, then we want to compare them, yep, by, yep, sorry, by their name. And you just have to say that. Okay, then comparing person, double colon, get name. And if we print them, we see that Kevin will be above Mike, which is already the case, of course. What if I say compare by the name length, maybe? That's it. So there I say, okay, let's take the name length of the people to compare them. And so Mike should be first this time. And that's it. Mike comes first. That's really beautiful because we are really saying what we want to do. Comparing ages, then comparing name lengths, then whatever. We can do whatever we want. It's really cool. And there is a second typo here. It is then comparing and not and then comparing. Sorry for that. So the second comparator only operates when the first results in an equality. That's legit. Another method of the comparator, maybe the last I see here, is the reversed method, which takes the comparison logic and say, okay, I want that, but in the other way around. So, for example, here, if I reverse all of that, we'll have the people compared by their age in the other way, so the oldest first and then the younger, and then compared to their name length, but the longer first and then the shorter. That's what we can see here. First Robert, then Anna, Amelia, Kevin, and Mike. This is the exactly opposite as we had before. That's it for the comparators and for this presentation. Thank you very much for listening. I just put the sources here. So there is the book Modern Java in Action. Actually, I read the Java 8 in Action, but this is just the new name for the new edition, which covers also Java 9 and plus. The Lambdas and Streams masterclass of José Pomar and Stuart Marks at the Devox, which are really interesting. And the code examples can be found on GitHub. I suppose we could put the link on the video later. So I don't know if there is some questions, maybe. No questions?
Hi, Foshwa. You can see the questions on the chat window.
Oh, sorry. Yep. I have to go on the chat. Yep. Don't know if I have it in my. Here it is. So
I can read out the questions for you.
Yeah, I saw them. Okay.
Okay.
So there is a question about parallel stream. What are they? So parallel streams are still streams, but they are treated in a multi-threaded way. So this is a practical way to do parallelism without having to do the boilerplate code. So I will just show a tiny example of how we can leverage parallel streams. So here, instead of doing a stream on the list, we just have to do parallel stream. And so the stream will be handled in a parallel way according to the fork join framework. I don't know if you know it, but the idea is to split a task until the unit to process is small enough. And then all the different tasks are processed in parallel. And so beginning here, we can just do whatever we want. So mapping things, filtering. When we will do the terminal operation, all will be executed in parallel streams. We just have to be careful that our functions don't have side effects because that won't end because threads will modify things and maybe that won't result in something we want. So just be careful of that. Actually, the Java 8 in Action book covers that really well. I see another question here. What does the flatmap function do? So flatmap function are to how do I say that? To reassemble streams into one stream. For example, if you do a map and you have a stream of stream, flatmap will say, okay, those are all streams. I can do only one of them with all the elements of all the streams. I don't know if I can put an example right away, because I don't have much possibilities to do that with the code I have here. But the idea is to keep processing items instead of processing streams. So it flattens the great explanation. Thank you very much. Can we use streams with primitive methods? There are primitive counterparts of streams. For example, I will take back, I don't know if I have it still, yes, right. For example, with the average of the people's age. Instead of doing what we did, we can do a map to double here. Map to int, sorry. That's it. So by doing map to int, we now have, of course, that's not right. We now have int stream. So that is a stream of integer, primitive integers, as you can see here, an int stream. So it's focused on treating ints, but primitive ones. So it's optimized for that. And we can, from this stream, take the average of the edges. That gives us an optional double, which is the counterpart of the primitive counterpart of an optional of double object double simply. So we have to say, okay, get as double as well. We know that we have a result here. And so if I do that, the average will be printed here. And it takes less much lines than what we did before. So there are primitives counterpart for pretty much every type. I think Boolean is the only missing, because I think it wasn't that much useful. So yes, this is possible to handle primitives with streams and optionals. And I see a last question. Can we convert an array to a stream? Yes, that's possible. The arrays utility class has been enhanced with stream methods that can take arrays, either primitive arrays, and they turn into primitive streams, or normal arrays, and they turn into an object stream. There is also the possibility to say, okay, I want to create a stream from that array, but only between those indexes. So that's pretty much how you do it. I don't have an array here, but you simply pass your array to the arrays.stream method, and here you go. That's it. I don't know if you have other questions. If not, I just want to thank you for watching, and yep. And I wish you best evening. Yes, I have a last slide with some things I read and I saw to go further into Java 8 and Java 9, 10, 11, and I don't know where we are now. Features, functional features. So there are parallel streams. We just talk about them. Primitive streams and optionals. We'll also talk about them too. The new features in Java 9 and above. There is a great video of functional programming patterns by Victor Rentia, and another one about adapting design patterns with lambda expressions of Venkat Subramaniam. So don't hesitate to check out those two videos. They are really, really good. So thank you very much for watching.
Thank you, Foshma, for such a great, amazing session. I personally understand streams better now. So if you like the session, please follow us on Twitter. Our Twitter handle is www.code_Delhi. And thank you everyone for joining us for this session. Good night.
Night.